Okay, so we're looking at the case where the power of tangent is 0. And this essentially means that since we're in case 2, we're looking at integrals of this form. You just have powers of secant showing up. Okay, so let's run through this case by case. The first scenario is if you are integrating just secant. And we just did this on the last video, and the integral of secant of x dx is the natural log of the absolute value of secant x plus tan x. So we took care of that case. What if you have you need to find the integral of secant squared x, right? We're talking about powers of secant now. That's just going to be tangent of x. The antiderivative of secant squared is tan because the derivative of tangent is secant squared. So we got that one. And now moving on to this third one, what about the integral of secant cubed x? This is where things start to get interesting. So when the power of secant is greater than or equal to 3, we are going to use integration by parts coupled with the trig identity, tangent squared theta equals secant squared theta minus 1. So let's see how this works out with our example right here. So if we want to find the integral of secant cubed x dx, we're going to use integration by parts. We need to know what is u, what is dv. Pull off secant squared x dx. Make that your dv, because then you know v is equal to tangent of x. Okay? So what's left when we pull off secant squared x dx is going to be secant x. And the derivative of secant x is secant tan. So du is secant x tan x dx. Okay? And integration by parts tells us that this integral of secant cubed of x dx is the same as secant x tan x minus the integral of, and I need v du, so it'll be tan times secant tan dx. So we'll have secant x tan squared x dx. Okay. And we can write this as secant x tan x minus the integral of secant x times secant squared x minus 1 dx. Why? Because we have our Pythagorean identity. So now we're going to distribute that secant x. So we'll have secant x tan x minus the integral of secant cubed x dx plus the integral of secant x dx. So in one move here, I distributed and I separated, and then I actually took this negative into account. Okay, so let me actually show you in slower motion what I just did there. So I want to say minus secant squared x, secant cubed x minus secant x dx, right? And then I can rewrite this as the integral secant cubed x dx minus the integral secant x dx. And all of this is being subtracted from secant x tan x, by the way. So now we get equals secant x tan x minus the integral of secant cubed x dx plus, because this negative and this negative cancel each other out, so plus the integral of secant x dx. Okay, so what we have here now at this stage is what we wanted, this integral of secant cubed x, and I'm actually going to, let's rewrite this, we're going to let I equal secant cubed x, the integral of secant cubed x dx. So then what we have is I is equal to, right, secant cubed, the integral of secant cubed x dx, is equal to secant x tan x minus I, right, because again, I is the integral of secant cubed x, minus I, plus the integral of secant x tan x dx. And we know that the integral of secant x tan x dx is going to be secant x because the derivative of secant x is secant tan. Okay, so we've got this secant x tan x minus I plus secant x. All of this is equal to I. Now what I'm going to do is I'm going to add I to both sides. Okay, so on the left hand side I'm going to have 2I. And on the right hand side I'll just have secant x tan x plus secant x. My goal is to figure out I, right? So that's what the problem started off with, was essentially what is I? Okay, and now I just divide both sides by 2. Okay. Oh, somewhere I needed to have a plus c. I can put in my plus c here. Plus a constant, plus a constant, plus a constant. Okay. So then I now have I equals secant x tan x plus secant x. So this is 1/2 of this, 1/2 of this, plus a constant. Okay. And again, this I really is our shorthand notation for the integral of secant cubed x dx. And
it's 8:45.
That's what we have. Oh, sorry, I'm trying to draw a little square here. It's not working. So I'll just do that. So this is our final answer.
It's 20:45.
And so again, in general, if you have a power, if you're trying to integrate just a power of secant and the power is greater than or equal to 3, the method is going to be to use integration by parts along with this Pythagorean identity. And when you use integration by parts, you're going to pull off secant squared, connect that with dx, and secant squared dx is going to be your dv.